Like 10 minutes.
Okay.
Welcome back to the class. Does it matter now?
No.
Hello, everybody. Welcome back. First, does everybody know when they have to go get their picture taken? I already took mine. So who's leading during this? When are we over 9:15? So, that's only you. That's it, right? No one else is leaving this period. Right? No one else is ORP? No. Never mind, so then, if I forget, somebody remind us when it's 8 and 10 minutes. I'll say it's 10 minutes later. First, I just sat down to start looking at the assignment that was posted yesterday, and boy, oh boy, through your whole class, there's maybe only 5 of you that did that. Okay, so be aware that it is a new 9 weeks. So if you're not doing an assignment and I put in a 0 because it's not in, that's really gonna look bad. It was such an easy assignment. Someone that did the assignment explained how simple it was. What did you have to do?
Are you gonna do take a picture or something circular?
RJ, Heather's explaining an assignment that only 5 people did. Were you one of the 5 people that did it?
Kind of.
No, not kind of.
Who's working on it?
No, you don't even know what it is.
Take a picture of something circular and then you find the meeting screen for the circumference and you circle the.
Right. Okay, so I don't know why so many of us are playing on our iPads right now. Again, I'm trying to make a point that there was an assignment posted yesterday for your homework, and all you had to do was find something, circle in your house, take a picture of it, and label your 3 parts.
I know that, but I couldn't find anything circular.
I forgot. Oh dang it! All I did was draw one.
No, you did it. You did it. But yeah, that goes for people in here and people at home too. Like, I just went to look at it, and maybe 5 or 6 of them were turned in. Okay, it's a new 9 weeks, so if you're not doing these assignments, it's really gonna look bad once I put it in at the end of this period. There was also some directions that you had to read. So if you didn't go in and click turn this in because you didn't read the directions, you're not gonna get points for that either, because there is like a new grading policy that is going into play through the new 9 weeks. I'm capping the late work at a week. So if it's something older than a week, you can't turn it in for points. I'm not going back any further because like the end of last semester was a mess. Mrs. Weston and I, some of your other teachers were talking that it's just too much to try and go back to something from September to figure out if you did it to turn it in. So you need to be keeping up with your work and turning it in. Again, if it's later than a week, you're not going to get points for it. Some of you that doesn't even matter to because you stay up to date with everything anyway, so this whole long speech of mine, don't even think about it and don't even worry about it. But you didn't do any of those 2 assignments from yesterday. In some spare time, try to do them because they're so simple, so easy. And then we have no issues. Okay, we are moving into lesson 5, which is still talking about circumference, talking about like wheels rotating and moving around. So if you go into your iPad, there's a Nearpod. If you prefer to use your book, we are gonna be on page 41. So we're doing lesson 5. I'm not doing all of lesson 5. If you are using your book, you're gonna notice that I'm kind of jumping into the middle. But you have 2 options. You join in the Nearpod or you can use your book. We do need calculators because some of the calculations we're doing today are messy. So I didn't mess those up. Not messy, they're just not like, what's 2 times 2? Just not easy to do.
2 times 2 means 4.
Why did I even decide to bring my science book?
Okay, so once you log into the Nearpod, it's gonna look like this, circumference and rotation. So we talked a little bit, we had one kind of a problem, there's like a propeller wing. We were trying to figure out how far, if there was something on the propeller, how far it would go after it spun once. Key thing to understand for all of this is that when we're talking about rotating a circle, the distance a circle rotates is the same as the circumference. So it's the same type of stuff that we've been working on. We'll give it another minute to let everyone log in. I like your haircut.
Yeah, I'm trying to fix my own.
Okay.
There's a,
Your haircut looks good.
yeah, see it?
Yep.
Yeah.
You ready for the picture?
Have you ever tried to fix this kind of thing before?
I have not. Okay, are we all good? Can you get in yet?
I'm in.
Okay, perfect. So first problem that we have, we are looking at, again, comparing rotation to circumference. It means the same thing. So we have a car wheel that has a diameter of 20 inches. So anywhere on that paper, draw a circle. That is a really
Not a circle.
freehand circle. Where's the diameter? So I want to label that. Where am I going to label it? Straight across. Your diameter goes from one end to the other. So that's my diameter. So we are going to say D equals 20.8. About how far does the car wheel travel in 1 rotation, 5 rotations, 30 rotations? So eventually we're going to make a table to make this easier. We're going to put rotation on the left. I'm just going to say rotate because it fits better. So when a wheel spins, your car is going further. So we want to figure out that in a rotation, how far does it travel? We're going to say distance. Okay. So when we're talking about the language of rotation, if I think about this wheel spinning, what do we call that measurement around the outside of a circle? The circumference. So if I'm looking for a rotation, all it is telling me, we'll find the circumference. So we want to remember that if we're looking for circumference, we take 3.14 or pi times the diameter. So if the diameter of my wheel is 20.8, our circumference would be 3.14 times 20.8, which is what? $65.3. So that tells us that when the wheel rotates once, it's okay. Yeah. Okay. Take your time, Parker. It's all good. When your wheel rotates once, it travels 65. Let's cut the decimals off because we're talking about 0.3 of something. It's not that much. 65 inches. That's what that means. Your circumference is just how far your wheel would rotate in one spin. Then it asks us about 5 rotations. So if it goes 65 inches in 1 rotation, how can I figure out how far it's going to go in 5 rotations? Multiply. So times 65. So we can see we're still kind of using that idea of constant of proportionality. 65 divided by 1 is 65. So the K value in the table would be 65, and I can multiply it through. So 5 times 65 is what? What?
325.
325. Again, just for the sake of easier math and easier conversation, we can ignore the decimals for today. Because if we're talking about inches again, 0.3 of an inch is really nothing. So it means nothing to us. So then it says 30 rotations. So how am I going to figure out how far he goes in 30 rotations?
We're gonna divide it.
I want to make my number bigger. See how 1 gets bigger, 5 gets bigger, 30 is going to get bigger.
You're gonna times it by carrying.
By what?
No, you're gonna times it though.
Times it by my constant number, or how many times I spin for 1 rotation. So 30 times 65 is what? 1,950?
Yeah.
So main idea is that rotation is just saying find the circumference. So 1 rotation is 1 circumference. If I rotate multiple times, multiply your circumference by that. You can organize it in a table to make it easier to see and understand on how to write through. Because now question B is asking us to write an equation relating the distance the car travels. It's telling us to use the letter C for distance, and it's telling us to use the letter X for how many times it rotates. So this is just what we did in Unit 2. How do I write a rule for this table? If I want to figure out the distance, we did something to the number of rotations. What did I multiply all of my rotations by? What number did I use the same for everything in that table? 65. So your equation is just a big long roll. I find the distance by taking rotations times 65. We can shorten it. And again, for some reason, they're telling us to use C for distance. So we can rewrite this as C equals 65. What letter did they tell us to use for rotations? X. Circumference and rotation all means the same thing. And then with these other problems where we're kind of scaling them up and scaling them down, we can use these tables to help us. So I'm going to rewrite another table down here to help us see the numbers. So we have rotations and we have distance. I know that one rotation was 65. That's quick. Tuesday the lines were so long. Like I was with students down there and they went back until like 2 periods later.
I was the only person there.
For real? They must be on their game down there. Because it was messy. By the time the second period came, all Tuesday, like I said, there was kids down there for 40, 50 minutes waiting in lines.
That was like a whole class period.
Yeah.
Class period and a half.
Okay, so again, I'm just rewriting the same table. One rotation is 65 inches. I need to figure out, I might actually freak out. I might actually freak out.
Wow. Wait, did this happen in your last class?
No, just now.
Has it not been happening at all?
In the patience that I'm practicing.
Has it never happened now?
I don't know why that just happened. There we go. Magic. Okay, sorry. My screen shut out, guys. Okay, I need to figure out how many times the car is going to rotate. So I need to figure out what the number on the left is going to be if I travel 1 mile. So there's a lot involved in this because my problem here is talking about inches. Okay, so we have to do some work here first. Does anybody know how many feet are in a mile? Someone look it up. How many feet are in a mile? Or, hey Siri, how many feet are in a mile?
No.
Yes.
You're always trying to talk to Siri, and I'm telling you, you're allowed.
What is it?
How many feet are in a mile?
Yeah, I can't do that.
On Siri on your iPad. I said, hey Siri.
That's for an iPhone 11. That works only for an iPhone 11.
So is your iPad on the 11?
I see you, Siri. 5,280. You're too late.
Up too late.
I tried to give you a chance. You failed.
I know.
There's 5,280 feet in a mile. All I'm trying to do right now is figure out how many inches are in a mile. Because if my whole table here is in inches, I just need to say, well, if they're asking me about a mile, I need to figure out the inches. So there's 5,280 feet in 1 mile. How many inches are in 1 foot? 12. So what I want us to do, take 5,280 times 12. Where'd you get?
63,360.
63,360 inches. So that is the same number. So if you travel down the highway and you go a mile, you're going 63,360 inches.
I didn't really do that. I just went on Google and then there's a generator you can do.
Nice. So yeah, so that's good to know because we're doing a lot of conversions here. I don't need you to memorize all of these, but they're telling us. Okay, so again, all I needed to know was that 1 mile was 63,360 inches. So we're going to put that in our table. 63,360 inches. How do I go backwards in a table to figure out the number on the left? If one rotation is 65 inches, How do I figure out how many rotations for 63,000?
63,360 divided by 65.
Right, so everybody in your calculators, 63,360 divided by 65.
You should get a laptop for this class.
To interfere with all of the other Wi-Fi stuff that we got going on and all the other tech issues that we already have.
Yes.
974.8.
So about 974, let's just say spins. It's the same thing, it's a shorter word than rotation. Again, same thing, we're really just filling out proportional tables. Multiplying to get to the right, dividing to get to the left. We had to do this extra conversion because it was asking about a mile. I can't talk about inches, 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 and then throw in a mile. I had to figure out how many that was. Okay? Are we okay with that? We're gonna do another one. Very, very similar to this.
Miss Lynn.
What?
If you just type in the pi symbol and hit enter, it puts 3.14.
Yeah.
3.14159
What?
2654. So on. Ow.
Thank you, because I forgot to hit it over here.
Remember Pi Day in 5th grade?
Hmm.
You went to the elementary school.
You're doing what?
5th grade.
Hiding?
Pi Day.
Yeah.
It was a day in March. We did an activity in here last year. Me and Mrs. Romeo worked together before.
Did you guys hide from your kids?
No, we sent them. There was like a scavenger hunt they did around the whole building.
Can we do this again?
We would, but we probably can't.
the Kubona.
Yeah, but it was really fun, and it's kind of sad because it was like the last thing we were able to do because Pi Day was like right before everything happened.
Yeah, in 5th grade, they did something where we went to each class and we did activities. And then at the end, the teacher got to get pied in the face.
Well, I'm not gonna let you guys do that. Maybe we'll see. This is the only other problem that we're doing because then I'm gonna help you guys do your homework. Great.
Pi 1.
This is the same thing. The only difference is that it says a bike wheel has a radius of 13 inches. So we're gonna do the same thing. Draw another circle.
0 divided by
A really
0.
good circle.
I think it looks like.
What's the radius?
What's the 0?
Oh.
The radius is 13 inches.
The radius is 13 inches, yes.
And you
So
have
if
to go
I
down the
wanted to
middle.
draw that into the circle, where am I gonna draw it in at? What? In the middle, so this?
No, across.
So that's my radius.
No.
Yes, it is.
Oh, yeah, yeah.
I was, yes, first I was
Testing
wrong on
you,
purpose.
testing you,
That's the radius.
testing you.
So again, it's the same question, look, 1 rotation, 5 rotations, 30 rotations. Rotation means find the circumference. So we're gonna do that, again, circumference is equal to pi times the diameter. But I don't know what the diameter is here. Because it only tells me that the radius is 13. So what is the diameter? My radius is 13.
Please excuse the interruption. Could you ask R.J. Thomas to come to the main office, please?
Yes, I will.
I'm not.
Thank you.
I don't really know.
Go down there for your mask pull.
I'll try.
Why do we know that our diameter here is 26?
Because since halfway is 13, just multiply that by 2.
Your radius is your halfway point, so the whole way would be multiplied by 2, so 13 times 2 means my entire length across is 26. So now we can just do it the same thing that we did. So if I want to find the circumference, Heather, find our circumference of our circle. 3.14 times 26. Heather, what is it?
You guys are all sleepy season. Sleepy season.
So I kind of like that a little bit. I'm fine with that.
Look, Shannon's telling you.
81.68.
81.68. So that's the circumference. So again, if we make a table and talk about the spins, I'm gonna say spin instead of rotation because it's an easier word. And the distance, if it spins one time, it goes, I'm gonna round this to about 82. Like I'm gonna take the 6 and round that up. It goes about 82 inches. So how do I figure out for 5 spins? What do I multiply 1 by to get 82? Chris? So then 5 times 82. 30 times 82. So in 5 spins, it goes about 410 feet. In 30 spins, it goes about 2460 inches. Sorry. Your answers might be a little bit different if you're not rounding. So if you use like 0.68, it's gonna change your answers a little bit. I'm rounding just to make it easier to type it all in. Question number 2 says write the equation. So we're talking about a bike. So it says use the letter V to represent your distance. And then it says use the letter X to represent your spins. So these numbers over here, the distance the bike traveled. What did I multiply all of the spins by to get them? Chris?
82.
We took 82 and multiplied it by how many times it spun. So we calculated the distance by taking 82 times everything over here. It says use the letter V to represent your distance, use the letter X to represent your spins. Then we have the same last question about how many rotations does the bike wheel make when it travels 1 mile. So again, we can extend our table down. I don't know what the rotations is, but I'm looking for 1 mile here. But again, I can't do inches, 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 and then jump to a mile. So I want to know how many inches that is. So that's the same thing that we just did. Does anybody remember what we said? How many inches were in 1 mile?
Well,
That's a foot. 12 inches in a foot, 5,280 feet in a mile. So then when we multiply those together, or look it up again, how many inches are in 1 mile? That's what we want to know. It was a 6 something. How many inches were in 1 mile? Chris?
33,360.
Right. So we want to know for a mile, but I need it to be the same. So I just look up how many inches are in a mile. So then again, in a proportional table, how do we go backwards? Okay. Divide by 82, because I did times 82, 5 times 82, 30 times 82. So if I have this number, divide by 82. So how many times does it spin in order to make the bike go 63,000 inches? 63,360 divide by 82. Jim?
772.79.
772.79 spins. So if you're riding your bike a mile, your wheel is spinning about 773 times. That's a lot. So are we okay with that? Okay, main idea when it talks about spinning, it's just another word to use for your circumference. If you need to scale it up, draw your table so that you know whether you're multiplying or whether you're dividing. Okay? At this point, those of you at home can get started on your practice problems, because I'm not going to go through the other problems in this lesson. You guys, we can do the homework together. Would you prefer that?
Yes, yes.
So if you're at home and you would also rather do the homework with us, I'm going to share the screen. You're not really going to be able to see me writing too much because you just can't. But you can stay in and kind of listen and follow along with us as we go. Click on your second task and your practice problems. Because then when you guys in the room come back, when you come back to ninth period, we're going to finish those projects. Remember those projects we started last week with your job stuff? But you guys are on the easy parts where you're just kind of making your big poster. It's not bad.
Business.
With your chef, remember you picked the chef, Parker? But we did all the math last week. Now you guys are gonna come back and just have to like put everything on a piece of paper and make it look nice. We all in the thing? We good? Says the diameter of a bike wheel is 27 inches. If the wheel makes 15 complete rotations, how far does it go? So again, rotations means find your circumference. So how am I gonna find my circumference of this bike wheel? We draw it. Here's your diameter, 27. How do we find circumference?
3.
Do it.
Thought you were gonna tell me my answer.
Take 27 times it by 3.14. Elena, what'd you get?
84.78.
84.78. So that's your circumference. That's one rotation. If it says 15, what would we have to do to finish?
Multiply that number by 15.
So take one complete rotation or one spin around, times it by 15, because you're doing it 15 times. What is your what is your speed?
127. Oh, no, 1,271.7.
1,271.7. Find your circumference. If it spins once, that's how far you go. If it spins 20 times, multiply it by 20. If it spins 500 times, multiply it by 500. Main thing to pick out of today. So are we good with that one? Click your next button. Because I just have you in control of it. The wheels on Kieran's bike are 64 inches in circumference. How many times do they rotate? So let's start with the table, because that's gonna be a little bit easier. So I have my spins or my rotations, and I have the distance. So they give me the circumference is 64. Your circumference is always how many times or how far it goes if it spins once. It's asking me how many times do they rotate, so what's gonna be over here if I travel 10,800 inches. So if that's my table, if 1 times 64 is 64, how do I go backwards to figure that one out? Sydney? Divide. 10,800 divide by 64. How many times is the bike spinning? Open up your calculator, or flip it over, type it in as we're going. Again, I'm doing your homework for you, so be a little enthused to work. Not everybody, maybe some of you. 10,800 divided by 64. Elena, what do you get?
168.75.
168.75. So if Kieran is riding his bike and he goes a distance of 10,800 inches, it means his bike spun about 169 times. Go with that. Next one. Circle A has a circumference of 2.6. So we're going to start with a picture. Here's circle A. My distance around is 2.6. Circle B has a diameter that is 1.5 times larger. I don't know what circle A's diameter is, but this one is 1.5 times as big as it is. If my circumference is 2.6, and I know that I have to multiply the diameter by pi to get it, how do I figure out what the diameter is? How do I figure out what times pi gets me to 2.6? Sydney? divide. So in your calculators, do 2.6 divided by 3.14. Type it in, Wyatt. What'd you get?
0.828.
Okay, so we can set there, we can round it, we'll say 0.82. So the diameter of circle A is 0.8. How do I figure out 1.5 times that? Take 0.8, multiply it by 1.5. 0.8 times 1.5. 0.8 times 1.5. What's our diameter of circle be?
Can you switch me back?
I didn't switch anything. This is a different app. This is your homework, this is your practice problems.
The second thing on Google question.
What'd you say?
1.2.
1.2. So the diameter of circle A is 1.2. If it's asking us for the circumference, then we're gonna take the diameter and multiply it by what? Diameter is 1.2. What do I multiply diameters by to get the whole bigger circle number? Pi. So 1.2 times pi is what?
Wait, what was the answer?
We didn't get it yet because I'm having you type it in. Do 1.2 times 3.14.
3.768.
So about 3.7. The circumference is about 3.7. The final answer.
I think you did 768.
Mm-hmm. I just chopped it off. Last one. A lot easier. Well, just a lot less numbers. We have a picture. It says the length of AE is 5 centimeters. We can see that here. What is the length of CD? What do we think? Trish?
10.
How do we know it's 10?
Because the B to A is 5 centimeters, you just have to roll the
Exactly, because that's my radius. So that means CA is already 5. So then multiply it by 2 to get 10. What is the length of AB?
Say pi.
That's 10. AB. A is in the middle to B. See? 5. So all of my radiuses are the same, 5, 5, 5. If it's the whole length, you multiply it to get 10. Name a segment that has the same length as AB. So what's a different segment that is going to be exactly the same as AB?
Is that 5?
F and A, yes. What's another one? F and A and G. What's another one? C and A and E. Any radius is the same length. Easy? This one's easy. So once you're done, you don't have to type all of these, you just need to type one of them, hit submit, and then you're done.
I worked down to the first one.
I don't remember. So in your calculator, do 27 times 15.
7.
I'm sorry, 27 times 3.14. 30. 4. Times.
Are we going backwards or forward?
Times. Big pump.
No.
So then, we're done with that. When you come back, you're working on your posters for that career thing we started last week. Those of you that are at home, sign back in ninth period, just see what you need to work on.
I ripped it away.
Stop putting your legs in your shirt.
I really want to go for some punchy, but I'm like,